Hi, this is Dale, and today I'm going to show you how to do a material takeoff and cost estimate for lumber framing using the new Quantifier in Profile Builder 2.1. I'm going to open the Quantifier, and first thing you want to do when you're doing any sort of reporting and cost estimating is you want to make sure that all the objects in your model are assigned to the correct layer. One way you can do that is by going to the Color by Layer feature. And here we've got 2x6s shown in purple. We've got subfloor in orange, 2x4s in a different shade of orange, and so on. So that makes it really easy to see which layer cost data is associated with a certain object in your model. So let's take a look at the 2x6s first. We don't have any cost data currently assigned to those 2x6s, but we do have them assigned to the framing 2x6 layer. So let's take a look at that layer. We don't care about the weight of the 2x6s in this case, but we'll add a cost line item. An optional cost code. Material description. We're going to quantify our 2x6s in terms of linear footage. So our input quantity is going to be feet, and our report quantity will also be feet. So our factor can be 1. We don't need to do a conversion. We'll assign a unit cost of 63 cents per foot with 10% waste and 8% tax, and hit OK. And now we should have a cost associated with that object, and $5.78. We can look at it in more detail with the cost inspector, and we can see here that that includes a 10% waste factor and 63 cents a foot and 43 cent tax. Now let's see how we can estimate the sheathing costs in this model. I'm going to open up the layer cost data for the sheathing. I'm going to first go to the OSB wall layer. So all of the wall sheathing has been put on that appropriate layer. So what I've done here is, rather than doing the cost in terms of square footage, I'm using this input square foot quantity and a conversion factor to convert from square feet to number of sheets of wall sheathing required. And then the unit cost now is in terms of cost per sheet rather than cost per square foot. So that's one way you can do it. Also, I'm using the same square footage quantity to determine the number of nails required. So I'm saying that 1.5 nails per square foot and a unit cost of about 3 cents per nail. So that gives me a total of the number of nails required and the associated cost for that. If we go to the subfloor costs, similar setup for that. We're just using a different unit cost here, but the same factors are involved. When you're trying to determine the costs in terms of area of walls and things like that, you need to keep in mind whether you're interested in accounting for the openings or not. When the sheathing is modeled using profile members, the area calculation is not going to include the reduction in area for the opening. That's just how the profile member quantity calculation works. It's based on the length of the profile member multiplied by, in this case, the height. If you're interested in the reduction from the openings, you'll want to modify, or you'll want to model the sheathing in a slightly different way. I would recommend just modeling it from a rectangle for each section of wall and then extruding it out the thickness of the wall. And then any openings that you cut in it will be reflected in the total area calculation. So now we'll look at the roof sheathing. And again, you have to watch how the area is being calculated. Here we're getting an area of 83.5 square feet. The way that area is calculated, it's actually based on the orientation of the bounding box for that object. And in this case, the bounding box is oriented in the XYZ orientation. But to get it more accurate, we actually should orient the bounding box in the same direction as the slope of the panel. So to do that, I'm just going to quickly edit the axis here, which is very easy to do. Just go to the axis modification tool, and we're going to align the axis with the panel itself. Close out of that. And now you can see the bounding box is in perfect alignment with that panel. And that's going to give us a better area cost, because now the area is going to be calculated as a projection of that direction along the slope rather than the way it was before. So now you can see the area is slightly adjusted now to 90.3 square feet. And if we select that face and compare it to the area of the face that SketchUp calculates, we see that they're the same. Now looking at the trusses. For this project, I'm not very concerned about the cost per linear foot of the truss material. I'm more interested in what the cost of the truss package is as a whole. So what I've done is I've created a group that includes all the trusses, and now I'm going to assign a cost directly to that group or to that object. So in that case, I go to Object Cost Data, and I've entered a description truss package, and I can assign a cost directly for that entire object. For the framing labor, probably the easiest way to do it is to just assign a cost for the entire model. Let's say I've received a quote for the labor for all the framing, and that way I can just enter that as a line under model cost data. In this case, I've put in $800 for the entire lot. The last thing we'll do is create a cost detail report of all the framing, a complete takeoff and cost estimate. We'll isolate all the framing objects by using a pre-made scene. Only framing is visible right now, so if we go to cost detail report, create that report, and there is our complete takeoff and cost estimate. Thanks for watching.